Morning and welcome to everybody. Thank you for joining what Zoom call a webinar, which is a new one on me. And this is the first time we've done this, so I hope the technology works okay. It's being hosted by our stockbrokers brand. Just so everybody knows, this is being recorded, and we'll put the recording up on our website. The presentation will take about an hour, or hopefully a bit less. And then afterwards I can answer questions, and I believe there's a facility where you can type in the questions, and we'll pick questions up and answer them. So this presentation, you should be able to see the the deck on your computers, and I'm going to run the presentation if, from the beginning, as if people don't know the company at all. I'm sure some of you know it quite well. So just bear with me, I'll run through some of the basics. So Chesterfield is a new venture. It was listed on the London Stock Exchange as a shell company in August 2017 at a price of 5p. And then we did an RTO, reverse takeover, in July 2018, and that was a price of 7.5p. And we raised £2 million, and we bought a suite of licenses in Cyprus and a couple of people that came along with them. And we've since kind of greatly expanded that project. So Cyprus, the word copper comes from the word Cyprus, the Greek word kuprum, and it was very big. In fact, it was the world center of copper in sort of classical times. It's part of the Tethyan belt, which has become quite in vogue in the last few years. It runs through the Balkans, all those discoveries in Serbia, etc., sort of through Turkey and across the Middle East. And so Cyprus is part of that quite famous geological belt. We're in the southern part of Cyprus, which is known as Greek Cyprus, but it's actually, it's not part of Greece, it's its own country. It's a member of the EU. And Cyprus was actually administered by the British through the 19th century until it gained independence. And so there are very strong historical links between Cyprus and the UK, which is kind of helpful for us. It's a very UK-oriented European country. They all drive on the wrong side of the road like we do. The law is based off English common law. There are lots and lots of Cypriots in London, and lots of UK tourists, or at least used to, go to Cyprus. And there are two big RAF bases on the island, which are actually British overseas territory. And GCHQ has its main listening post for the Middle East there. So it's relatively easy for us to operate there. Unlike people, I think, operating in France or Spain, and some of those countries find it kind of challenging. It's quite a UK oriented place. And also, these days when you're looking at jurisdictions as a mining company, high up on the list is, are you going to run into headwinds from environmentalists, which has been a problem in places like France, for example, and Portugal. In Cyprus, I would say that most of the young kind of trendy students kind of tend to go and study abroad. So it hasn't really got that kind of cadre of sort of protesters that you get elsewhere. And also where we're operating is in the mountainous, well, the foothills of the mountains, are well away from the coast, and they're very sparsely populated. So, I think we have less of that kind of risk than elsewhere, which is important. When you go to Cyprus and you go up into the areas where we are, it's full of these big old open pits, usually full of water. And here's a picture of 4 of them, but there are loads of them. And it really is striking when you get there. You understand that this was, in the 60s and 70s, a big mining area. It had something of a kind of boom at that time. And, some people, under the impression that the deposits in Cyprus are all very small, but that's not the case. There are some very big deposits. The largest, Mavrouni, was 16.5 million tons at 4.5% copper. And so that's like a kind of world class copper deposit. So we're definitely capable of finding big deposits there. The peculiarity of Cyprus was that the whole mining industry kind of halted pretty much in 1974 when the Turks invaded. And so it's been somewhat frozen in time for the last 45 years. And this is a very important point for our exploration kind of thesis, is we're going into an area that ordinarily would have had a lot of exploration over the last kind of 40 odd years or so, using new technologies. But they, you know, in the decades after 74, Cyprus is still considered kind of pretty risky. The commodity prices fell, particularly copper, with the end of the Vietnam War, and there's decreased demand for munitions. And also, people were discovering, you know, big copper discoveries in Latin America. And so Cyprus kind of really got left behind. And that presents a great opportunity for us. It's very unusual to be able to go to a formerly mined, you know, very, very productive area and pick up 45 years from where people left off. And if you go up to our license areas in the hills, it's really evident that, you know, this is a very highly mineralized area. There's stuff sticking out of the walls everywhere. Where the guys are on the left, actually, there's a kind of Roman mine right underneath there. And so the place is littered with ancient mines and new mines and mineralization. And it lends itself very well to a site visit. Or rather it used to, I suppose, these days. So I want to go into the geology, and if you can just bear with me on this, because it is important to the investment proposition to understand the geology. And I'm going to explain kind of rather simplistically what it is, and it will help you understand what it is that we're doing, and some of the slides I'm going to come to later. So we're looking for what are called VMS, which is volcanic massive sulfide deposits. So what are those? Well, most, you know, mineralization, minerals in the Earth's surface all come from underneath, from volcanic activity, primarily. And you know, if you think of a volcano, you know, you and I would tend to think of a volcano on land, you know, with lava coming out of it, like in Hawaii or something. But most of the Earth is covered by the sea. And under the sea, volcanics actually aren't primarily lava, they're actually kind of with water. And what happens is, if you imagine, say, the middle of the Atlantic Ocean, where the two big tectonic plates are hitting each other, and it's a very sort of volcanic, you know, the ring of fire, they call it. Every time a fissure opens up, seawater pours into it. And that water then starts circulating underneath the seabed and starts picking up minerals. And being volcanic, you know, they're sort of sulfurous minerals. As you go to a volcano, you can smell sulfur. There's always sulfur associated with volcanic activity. And so it picks up these metals as it kind of moves around underground, under the sea floor. And, you know, they pick up copper, gold, zinc, silver. And what happens is then that this superheated water makes its way through to the surface, to the seabed, and vents out at very high pressure. And if you look at that photograph on the left, that's called a black smoker. You know, we've all seen them on National Geographic, etc. So you've got this super hot water. And the reason it's kind of black is it's full of minerals. And at the bottom of the sea temperature is very, very low. It's kind of 1 or 2 degrees. Even in the tropics, it's very, very cold at the bottom of the ocean. So you have this super hot water venting out, you know, these black smokers, and it immediately starts to cool down. And as it starts to cool down, it precipitates this sort of ash. You know, rather like, you know, if you imagine, say, Pompeii, and you have a volcano going up and there's this kind of ash fall, well, imagine the same thing happening under the sea. And so if you look at the diagram on the right, that's a schematic of what is called a VMS lens. So this is volcanic, and it's full of these sulfides, why it's called volcanic sulfide. And the reason it's called massive, in this context, massive actually means that it's more than 50% of the material is sulfides. So massive doesn't mean big, or it doesn't mean big crystals. It just means that the majority of the material coming out of these kind of high-grade sulfides. So the water vents out, and it forms this kind of pile of ash that you see on that diagram, and that typically might be about 200 meters across, and maybe, you know, perhaps say 50 meters deep. And it forms into this kind of pile, and it's called a kind of lens, the shape of a lens, which is why we call them lenses. Now, what's important to understand is that when this is all happening, the different kind of sulfides, gold sulfide, copper sulfide, zinc sulfide, cool down at different rates. And as a consequence, the way it kind of works is that the gold tends to get deposited at the bottom, what we call the feeder zones, which is the little veins where the water is making its way to the surface. The copper is kind of in the middle, and the zinc's on the outside. So if you just retain that kind of idea in your head of a deposit, it's high grade, it's about 200 meters across, and the gold's on the bottom, and the zinc's in the middle, the copper's in the middle, and the zinc is on the outside, because we'll refer to that a bit later on. Now, something that's really important to understand about VMS deposits is they don't come along alone. They come in clusters. And if you have a look at that schematic, that graphic on the upper left, that's a sort of a painting of what these things look like on the deep ocean floor. So you'll get a fault, and you'll get a whole row of these things all venting away. And they're quite often, just a kind of 50 or 100 meters apart from each other. And sometimes they're so close that the lenses actually kind of join together, so you get these kind of bigger deposits. The other what happens then is after a period of time that they stop, and they kind of get exhausted and run out. And then typically you may get sediment on the sea floor will cover up these lenses over thousands of years. They get covered in silt, or as often happens with our deposits in Cyprus, there's a volcano, a lava volcano goes off somewhere close by, and they get covered in lava. Either way, what then can happen is a period of time later, maybe 1 million years later or what have you, that the same fault is still there, and another load of these things go off. And so not only will you get them in clusters, but they're also stacked on top of each other. And again, that's important to understand for what we're doing and what we're looking for in Cyprus. So if you have a look at that little diagram of the kind of orangey colored dots, bottom left, that's something I took from the Canadian Institute of Geology. And those are different mines around Canada. They're very famous VMS mines, Flin Flon, Snow Lake, Noranda, etc. And those dots are all different VMS lenses. So the point we're trying to make here is that VMS mining projects aren't just one deposit. There are usually a whole load of deposits which they've found in close proximity. And that's what we're looking for in Cyprus. We're not just looking for one deposit, because as I say, they're relatively small and high grade, but we're looking for several deposits to put together into one mining project. So coming to Cyprus, there's a map of the on the right, and all those little crosses are mapped known deposits or old mines. There are around about 200 of them. And that's, Cyprus is not a particularly big island. So those are dotted in that kind of roughly in a kind of circle around the mountains. So they're in the foothills of the mountains, and they're in a relatively constrained space. But as you can see, it's extremely perspective. And in each of those crosses is roughly, one VMS lens that they've mined. Now, you may look at that and say, well, haven't they mined everything? Well, the important thing to remember is that all of these mines from the sort of 70s back were from deposits that they found on surface, or they found a bit of it sticking out of the surface, a surface expression, as we say. What they didn't have the technology to do was to look underneath the surface. And, you know, as we've just learned, that these things, they come in clusters and they also come in stacks. And so where you see a lot of these deposits on the surface, you know for certain that they're going to be a whole load of them underneath the surface, which they couldn't find. And this is the point about the fact that Cyprus was frozen in time in 1974. They didn't actually have the technology, they didn't have the geophysics and the helicopter airborne and all these other fancy techniques we have now where you can look beneath the surface. And until we've come along, nobody's really actually been to Cyprus and done a systematic exploration survey to find buried VMS deposits. And so that's what we've come to do, and that's our kind of strategy. That's why we're there. So are we certain that these deposits exist? Well, yes. If you take a look at that photograph on the right-hand side in the circle, that is a buried VMS deposit. The bit at the bottom in the lighter color material. And across the top, you see that sort of pinkish mauve material. That is one of those underground lava flows I was talking about. So that would have been the VMS deposit at the bottom. That would have been a lens from a black smoker, and then it's been covered by a flow of lava. This particular example is actually sticking out from the side of a hill, which is how they found it. And they've dug a big trench in to mine it, and I think they got to a point where the lava on top of it was just too big for them to handle, so they stopped mining it. But that is almost like a kind of textbook diagram, this photograph. And that's exactly what we're looking for, and we believe that there are going to be many, many more like that. So these are our license areas in Cyprus. If you remember the diagram a few slides ago with all the little crosses on them, all the mines, and they're all in that kind of semicircle. Well, they're on that area that's colored light, sort of like a light lime green. That's the prospective belt. And those kind of black and red shapes are our license areas. The blacks are the ones which are already permitted for drilling, and the red areas are ones which are in application, although I should say that recently some of those have been granted, so actually a lot of the red is now turning to black. And what you can see there on the north and the south flanks of the Troodos Mountains, those green areas, we've taken pretty much all of the available land. So we've got a really, really good land bank. We're by far the dominant license holder in Cyprus. So we've got the land, and the other thing you need, obviously, are people. And I know that certainly every mining presentation I go to, everybody says, well, they've got like the best team, they're great, etc. But for a microcap company, we really do have an absolutely world-class group of geologists we've managed to attract. Dave Cliff was head of exploration Europe for Rio Tinto, one of the world's biggest mining companies, as you probably know. He's a director, extremely senior, experienced guy. Mike Parker, who's joined us as COO, was with First Quantum for 20 years. And First Quantum is a very famous, very dynamic mining company. Mike was a very, very senior guy there. He was involved in two major copper discoveries, Longxi and the Frontier Mine. In fact, he named the Frontier Mine. He was also head of DRC and then head of Peru, and had very large exploration teams working for him. And Neil O'Brien, who's joined us as a technical consultant, was one of the founders of London Mining. Again, a world-class mining company. He was effectively their head geo. He was head of new business development, and now he's with us. And Neil is a Canadian. He's a world authority on VMS deposits, an extremely experienced guy. So we really do have an A team working for us. We spent 2019 was a lot of hard work, and this was developing our target list, which is really the meat and potatoes of an exploration company. It's not particularly glamorous. It's not the kind of thing you put a lot of announcements out, but it's just a huge amount of detailed work, and we spent quite a bit of money doing it. And we say we have a very, very thorough team, and so they're applying, world-class, big company, Rio Tinto style exploration program in our little company. We kicked off with a satellite suite using the sensors on it. It's a Sentinel-2 satellite owned by the European Space Agency, which we commissioned, and they took very high definition photos, and also they can calibrate the sensors to look at the non-visible spectrum according to our specifications. We had that information analyzed by a specialist company in the States, and that is a way of finding all the kind of faulting systems that wouldn't necessarily be visible to the naked eye from space, and saved a huge amount of time of field work, etc. We've been running geophysics. We've done a lot of geochemistry, particularly soil sampling, which is a very effective but very time-consuming technique. We take loads of these samples, which are very carefully logged and then sent to a lab for analysis. We've done a lot of mapping and field work. You see one of the guys there with an XRF gun, which we have, and we've done a certain amount of drilling. We've also done a lot of work in the National Archives. There's huge boxes of kind of dusty files, in Greek, which we all have to go through and have translated. But it's very important as part of the detective work for ascertaining what has happened in the past. And all these various different techniques are then sort of layered together and then analyzed by the team, who, with their experience, look for clues and look for coincident data of where they think these deposits may be buried. This is really just a sort of a graphic that shows that there's a kind of big process that goes into developing these projects, these targets. And I would say that the difference, I think, between us and some exploration companies is the amount of work we've put into building up this target list with the various different layers of work. And I know, that there are some exploration companies that don't really bother doing all of this. They find some good land and they wave their arms around, and then they get out a diamond drill, which is an extremely expensive tool, and start drilling loads of holes, and they normally miss. And when they've finished doing that, they come back and ask for more money and drill more very expensive holes. In our view, diamond drilling is what you do right at the end of a very long process to really narrow down your target list and close in on the best targets. So this slide is probably the most important slide actually in the whole presentation. So that there on the left is our target list. It's the first area which we focused on, our Troodos West area, and there's something like 30 targets there. And bear in mind that area is about 10K by 10K. So that's a relatively small area. Each of those targets is a prospective buried VMS deposit. And our hope is that we'll find 2 or 3 of those, which would be enough to put together a small mining project. And obviously if we find 4 or 5 or 6, then that's going to be a bigger project. But they're all close enough that you could build a centralized processing plant and just truck the material from these various different VMS deposits. These are a couple of slides. These are actually some of our kind of internal slides, but there's some different types of VMS. It gets more complicated the more about them, the more you know about it. But these are the ones which are sort of like the black smoke, as I was talking about at the beginning. And on the right-hand side there, you can see that these are the names of the various targets and those numbers are the estimate of how deep we think they are. So, for example, Kin Valley, we think sort of 25 to 50 meters deep. Sliver is maybe 50 meters deep. Kin Plains maybe 150. But the point being is that these are all pretty shallow deposits. They're sort of, you know, anywhere from you know, maybe 25 meters down to perhaps 150 meters down, but that's you know, pretty shallow in mining terms. This is another type of deposit which we're going to talk a little bit about in a minute. This is sort of actually a black smoker that never got to the surface, and the materials got trapped beneath the cap rock, a little bit like oil and gas can get kind of caught and trapped between a cap rock, which are called strata bound. And we think, though, we have quite a number of these, and in fact, we're working on an RNS, we'll hopefully get out next week, that helps explain some of the targets of this type. And this is something that's actually being triggered by our percussion drilling, which I'll come on to. So gold, obviously something's attracted attention. We think we have quite a lot of gold. And Cyprus has never really been known for gold. It's always been viewed as a sort of copper place. And the reason for that is when they were mining in the 60s and the 70s, gold was pegged by the Bretton Woods Agreement at $35 an ounce. And so all through that period, the price was just too low. I mean, if you think now the price is $1,700 plus, that's 50 times more than it was in the 60s and 70s. And also at that time, they didn't have the assay technology to detect it. They couldn't really sort of detect anything much below about 3 to 4 grams a ton. And you know, now we can detect levels much lower than that. So even if they had gold, very often they didn't even know it was there. And if they did know it was there, it wasn't really worth, the price wasn't high enough to justify mining it. Then they released this peg on the gold price in August 1971. And if you have a look at that graph on the bottom right, that's the price of gold on the top in the yellow and the price of copper in the copper color at the bottom. And you can see how the price of the two disconnected. And actually they disconnected in 1974 in a significant way, which coincidentally was the year that the Turks invaded Cyprus, and so kind of everything halted. And when it disconnected in the mid-70s, that sparked a huge bull run in the gold price and you know, and a massive boom in gold exploration globally. But again, that passed Cyprus by. So in the same way that Cyprus never got explored for buried VMS deposits, it never got explored for gold either. And it's never really been considered as a kind of gold place. And you know, I think, you know, we're as guilty of that as anybody. We went to Cyprus as a copper play. You know, our investor group came together to look for copper, and we thought Cyprus presented a really good opportunity for copper, but we weren't really looking at it in terms of gold. What happened is a few months after we did the RTO, we did some drilling where there are a few targets we wanted to take a look at. So we did some preliminary drilling for copper, which we didn't really find, but we found an awful lot of gold, which surprised us. And you can see there some really pretty good grades. We got, you know, 29 or 30 meters really from surface, 1.1 grams per ton of gold. We found another intersection over 10 meters at 3.8 grams, which is kind of really pretty high grade, and gold elsewhere. Since we did that drilling, which we thought was interesting, the gold price has risen some 40%. And as you know, last year, you can see from the price chart on the right, is a 1-year chart, was good for gold. Obviously, with the COVID crisis, gold's taken another step up. we had a lot of investors suddenly calling us up saying, well, you know, didn't you guys find quite a lot of gold? What's your view? And so internally, we got our very senior technical team together and said, look, can we run an evaluation exercise on gold? And these are guys who are pretty hard to impress. They're generally very conservative, and they came back with a very, very positive view on the gold. They said that the VMS system that we're in Cyprus is a particularly gold heavy system, and that the gold is also very clean, which is very important. It doesn't have other sort of elements in there sort of messing up the purity of the gold. And the way it kind of works is that the gold is mixed in with the copper, and when you process that in what's called a concentrator, what comes out the other end is a kind of white kind of powder, which has got both copper and gold in it, and that would be shipped to a smelter somewhere in Europe. And the smelters are really keen that this is a kind of you know, a clean product. They don't have to filter out, you know, other materials from that, and so we think that the product, not only will it have a high gold content, but also it's a very desirable clean product for the smelters. So, you know, the gold price is obviously booming again. You know, we don't know how to predict the price of gold. I'm not convinced many people do. Bank of America think it's going to $3,000 apparently. But I think it's safe to say that, you know, the gold price is likely to remain robust through this year as people try to figure out what the fallout of the COVID epidemic is. So we think that, you know, gold is going to form an important part of our kind of revenue from our discovery pipeline. That survey, this is a zoom in on the target list you saw from the previous slide, and we've added in these kind of golden symbols, which is where we found gold from our drilling, but we've also found gold from some archival work as well. And you can see those on the right, there's some pretty high grades. And you know, what's encouraging is that they've got plenty of other targets where the gold is untested. So we think, you know, as we start drilling, we're going to find more and more gold in our target list. And certainly the gold, it seems to be on a kind of trend, on a kind of fault trend, which is very encouraging, because where you find it on one part of the fault, you're likely to find it on the other targets in the fault as well. So I just wanted to run you through, as an example, one of our targets, and each target's got a different story. But I think this will hopefully demonstrate to you the amount of work that's going into these targets, and why, having done all this work, we think we stand a very high chance of success from the drilling. So what you're looking at here are two photographs. So one on the left is one of these big old open pits. It's actually a particularly big one called Limni. And then about 1 kilometre to the south, there's another area where you can see all that material piled up, and that's an old sort of mine workings. And we weren't really sure what was going on there, but obviously they've been mining something. And actually on the left of that photograph, you can see our drill at work, and that's where we hit one of the big old gold intersections. That 29.8 meters was from that drill. So now we're looking at a satellite photograph. You can see the Limni pit on the top, and that other mining area at the bottom, about 1 kilometre away. From the satellite analysis, we know there's a big fault along there, and we did some soil sampling, which looked good. And then we decided to run a geophysics survey called an IP survey with these sort of kind of cattle prods. Type machines that you insert into the ground, and it takes an electrical read. That's quite a big and quite an expensive survey. And we thought we were going to find something in between those two lines, but actually the readings came up surprisingly on the lower left, and we're trying to figure out what was going on. About the same time, we went into the archives, and at the bottom of a dusty drawer somewhere, we found this, which had been produced by a French exploration group, a government group called BRGM, that looked at it in the 1980s. And what we found out from this, and we found out from other historical work, is that that mined area, they'd done some mining on surface, had actually mined a whole load of copper from the surface. And you can see that on the right-hand side of this diagram. You can see our drill holes, those kind of lines, and what's called a root zone, and that was all the gold that was left behind underneath. And if you remember, if you go back to when I was describing the lens, how the gold was something that formed at the bottom from the feeder zone, the root zone. So what had happened is that they'd mined the copper on the top. They'd actually assayed the material that they left behind, and they only found trace gold because their assays weren't accurate enough to to identify, 1 gram a ton. So it was all left behind. And then what happened is a fault, and which is, if you look at that kind of sort of squared, sort of circular square, there's a line, a diagonal line going through on the right-hand side, and that's a fault. And what we believe had happened is this whole thing had shifted down, so that the gold and the copper on top has shifted down to 30 or 40 meters. And the fact the French had drilled a hole through it, and lo and behold, they went straight through some copper rather, but they didn't assay for the gold underneath. So we're pretty certain that we're going to drill there, but we're very, very certain there's copper there, and we're pretty certain we're going to find that associated with the gold that shifted down. This slide is actually a more modern version of the drawing that the French did. This is our modern geophysics that sort of shows something similar, and the anomaly that it's showing up is exactly where the French thought it would be too. So we've got a sort of an extra layer of kind of evidence on that, and we can see where the French drilled their hole. EW10 on the bottom slide is coincident with where our geophysics is showing we think there's going to be a deposit. So what this the target's called Evelyn, and what all this shows is it's a coincidence of all sorts of different types of work, of satellite work, of soil sampling, of geophysics, of archival work, of our knowledge of the geology, and they all come together to form a target, which is this is a high-grade target, and we think is one that's very likely to yield good results. This targeting work that I described took quite a long time, and we were hoping to drill sort of late summer last year. But as we have kind of weekly operational meetings, and we discuss all our targets and the ranking of the targets. And as we're getting into July, August, they kept finding new targets. And we'd have a meeting. They say, we found a brand new target. It's ranked number sub 12 or something, but we think this could be a top 5 ranked target. So we say, okay, well, let's carry on. Let's work on that. And that process carried on sort of through September, October, and we didn't think it was a good idea to drill until we'd actually finalized this target list, because we wanted to optimize that target list. And there's no point starting to drill and you're finding kind of, the new targets are being brought up into the higher ranking. So we finalized that target list around about November. At that point in time, it's really kind of getting out of the season for diamond drilling. It rains a lot, and with the rain, you get a lot of lightning and thunderstorms, and you can't drill when there's lightning around, because obviously the drill's like a giant lightning conductor. So we did come up with an interesting proxy, which was to use something called a percussion drill. Percussion drills are generally used for drilling things like boreholes for farmers, to get water. But in this instance, they're pretty useful. They're quite an aggressive drill. They tend to kind of smash the kind of material up a bit, so you don't get a core like you do from a diamond drill. But if you're going through a volcanic massive sulfide deposit, it will definitely pick that up. And it's also very quick to drill these holes. You can do like a hole in a day. And it's also very cheap. The results you get out of it from the logging of these kind of chips is not accurate enough to be able to announce to the market as kind of data. But it's good enough to say it's good enough for us to detect these holes. And the only problem we had is the truck is very big. It's like the size of a London bus. It weighs 30 tons. So it's quite difficult to get it around in kind of this wet weather. But we did manage to drill 2 holes, 2 targets rather. We drilled 4 holes on each, and 2 holes on each hit VMS. And that was a really, really good result for us. It kind of proved up our theories and the reasons that these targets had been selected. And the geos were very excited about that. And say 2 out of 2 is a really great result. This is a schematic of one of those targets called Hillside. And those are 4 holes that we drilled down. Hole number 1, I was on the phone from London asking the obvious thing, well, have we hit anything yet? And they said, yes, we've hit this kind of intrusive material, which isn't a VMS, which they were very excited about. And I was kind of wondering, and they said, well, no, this is a trap. If you remember that diagram we looked at where the material, the VMS is trapped, and they found the trapping material, and they drilled another hole, hole number 2, which went through trapping material, and there beneath it was trapped a VMS deposit. We drilled a further hole about 50 meters away, which is hole 4, and we hit the same. We're pretty certain it's the same thing again. And this was high in zinc. And if you recall, zinc is the thing you tend to find on the outside of these lenses. And so this would suggest that we've hit maybe the outer edge of the lens, and that the lens is much bigger, and is going to be more copper and gold rich towards the middle. So when we start our percussion drilling up again, this is one of the targets we're going to hit. We're going to see if we can find more of this VMS deposit. And we found quite a lot of gold associated with it. We assayed at, a lot of it came in at 1 gram a ton plus, and we think actually once we get the diamond drill in there, the grades may well be higher. So that's sort of the main part of the presentation. I would say the area we've explored so far, Troodos West, is just one of our areas. We've got quite a few other exploration areas behind that. So once we finish Troodos West, we've got plenty of other license areas in the pipeline. That's our executive team. One feature of Chesterfield is very low market cap, which means there's plenty of upside on discoveries. And I think just one last slide. We think about it,
and then write down what you want to do, because that's the plan. Yeah, and then I'll come back to you, because I just need to listen to this.
People ask a lot about COVID. And I think we're quite a good play on sort of the coming out of the COVID lockdown. Cyprus has probably got one of the best controlled epidemics in Europe because it's an island, and because the epidemic struck during the tourist low season, well, no tourists there, they're able to lock it down very quickly. And also, it's got quite a strong militaristic element in Cyprus. All the men do military service, so it's quite a disciplined place. And they've only had 12 deaths to date, and very low infection rates. So we think that Cyprus will relax its COVID lockdown restrictions as quickly, if not quicker, than elsewhere in Europe. And we can get going immediately with our percussion drill. We can call these guys up, and we can get the drill there, within days. So of the junior miners, we think we'll be one of the fastest out the traps to get going. We'd effectively just started our percussion drill program when it got interrupted by this epidemic. So we're really just going to be picking up from where we left off. As we've discussed, gold is a strong part of what we do, and gold is seen as a COVID play. We've got a very low market cap, micro cap really, and as many of you would have picked up upon, we've actually started to pick up quite a lot of liquidity. So we've got a nice combination of a micro cap company that's pretty liquid and will get going pretty quick from the COVID lockdown. So that concludes the presentation.